everybody, it's Tam, and I'm at CES, as you can see here. And I wanted to do a quick little forward before we got into the technical explanation and the recap. I was there in the audience when Jensen was delivering the keynote, and it was one of the most mind-blowing, expectation-surpassing presentation that I'd ever seen. It was so mind-blowing that it was easy to get lost in the sauce. So that's why today I'm making a recap that cuts through the presentation fluff and focuses on the core technical details. I split the keynote into 7 sections, staying in the same order that Jensen presented it in, and throughout it, I'm going to add context and commentary to help deepen the understanding. So prepare to be amazed, and if there's any questions or thoughts, you know what to do.
GeForce enabled AI to reach the masses, and now AI is coming home to GeForce. That was real-time computer graphics. No computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. It has been trained on a supercomputer back in Nvidia, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. This whole graphics card is just one giant fan. So the question is, where's the graphics card? It's literally this big. The voltage regulator design is state-of-the-art, incredible design. But we managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1299, this 5070 laptop has a 4090 performance. So can you imagine? You get this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense? Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate, using artificial intelligence, all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing is the family of GPUs we're going to put in here. So, ladies and gentlemen, the RTX Blackwell Family. Well, Blackwell is in full production. This is GB200 NVLink 72. Every single cloud service provider now has systems up and running. We have systems here from about 15 computer makers, 200 different configurations, manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Now, the goal of all of this is so that we can create one giant chip. You see that? That's cool. Look at that, disco lights in here. All right. If we had to build this as one chip, obviously this would be the size of the wafer, but this doesn't include the impact of yield. It would have to be probably 3 or 4 times this size. But what we basically have here is 72 Blackwell GPUs, or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room's supercomputer only recently achieved an exaflop. This is what we're trying to do, and this is the miracle. This is the miracle of the Blackwell system. Well, one of the most important things that's happening in the world of enterprise is Agentic AI. We've created 3 things for helping the ecosystem build Agentic AI. Nvidia NIMs, which are essentially AI microservices all packaged up. It takes all of this really complicated CUDA software, CUDA DNN, Cutlass, or Tensor RTLM, or Triton, or all of these different really complicated software, and the model itself, we package it up, we optimize it, we put it into a container, and you could take it wherever you like. And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models coming for physical AI. And these AI models run in every single cloud, because NVIDIA's GPUs are now available in every single cloud. It's available in every single OEM. So you could literally take these models, integrate it into your software packages, create AI agents that run on Cadence, or they might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run the software. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say. And we even give them access to certain information. The IT department of every company is going to be the HR department of AI agents in the future. And on top of that, we provide a whole bunch of blueprints that our ecosystem could take advantage of. All of this is completely open source, and so you could take it and modify the blueprints. We have blueprints for all kinds of different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the Nvidia Llama Nemotron language foundation models. Llama 3.1 is a complete phenomenon. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. These models are incredible. It's a number one in leaderboards for chat, leaderboard for instruction, leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you. Next giant AI service period is software coding. 30 million software engineers around the world. Everybody is going to have a software assistant helping them code. If not, obviously you're going to be way less productive and create lesser good code. And so this is 30 million. There's 1 billion knowledge workers in the world. AI agents is probably the next robotics industry and likely to be a multi-trillion-dollar opportunity. Okay, so AI was created in the cloud and for the cloud. You could also put it inside your company, but the thing that we want to do more than anything is put it on our PC as well. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2 basically is 2 operating systems within one. It's developed for developers, and it's developed so that you can have access to bare metal. WSL2 has been optimized for cloud-native applications, and very importantly, it's been optimized for CUDA. As a result, everything that I showed you with NVIDIA NIMs, NVIDIA NeMo, the blueprints that we develop that are going to be up in ai.nvidia.com, you download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live. And so this is an incredible thing for engineers and developers everywhere. Let me show you something that we can do with that. This is one of the examples of a blueprint we just made for you.
Generative AI synthesizes amazing images from simple text prompts. Yet image composition can be challenging to control using only words. With NVIDIA NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene. They start by laying out 3D assets, created by hand or generated with AI. Then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt. Assisted by Generative AI and Nvidia NIM, an artist can quickly realize their vision.
Today, we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things, things that are fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. Physics grounded. Not physically grounded, but physics grounded. It's algorithmic physics, principled physics simulation grounded system. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application, the use cases are really quite exciting. And of course, for robotics, for industrial application, it is very, very clear. The platform has an autoregressive model for real-time applications, has diffusion model for very high-quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end-to-end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available on GitHub. Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. And we've been talking about this for some time, is this three-computer system. Instead of a three-body problem, we have a three-computer solution. One computer, of course, to train the AI. We call it the DGX computer to train the AI. Another, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or in a stadium, or whatever it is. These computers are at the edge, and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios. Then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. I'm super, super pleased to announce that today, Toyota and Nvidia are going to partner together to create their next generation AVs. I predict that this will likely be the first multi-trillion-dollar robotics industry. In just a few of these cars that are starting to ramp into the world, our business is already $4 billion, and this year, probably on a run rate about $5 billion. Well, today we're announcing that our next generation processor for the car, it's called Thor. This is a robotics computer. This is a robotics computer. It takes sensors and just a madness amount of sensor information. Umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a humanoid robot, it could be the brain, it could be the manipulator. This processor basically is a universal robotics computer. The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. The only and the highest. And so I'm really, really proud of this. ASIL D, ISO 26262. It is the work of some 15,000 engineering years. This is just extraordinary work. And as a result of that, CUDA is now a functional, safe computer. And so if you're building a robot, Nvidia CUDA, yep. And well, I have one more thing that I want to show you. DGX-1 revolutionized artificial intelligence. I just wish that DGX-1 was smaller. And this is NVIDIA's latest AI supercomputer. And it runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB200, the smallest Grace Blackwell that we make. This is the chip that's inside. It is in production. We're expecting this computer to be available around May timeframe. And so it's coming at you. It's just incredible. Let me tell you what I told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. One amazing AI foundational world foundation model, the world's first physical AI foundation model. It's open, available to activate the world's industries of robotics and such. And 3 robots. We're working on Agentic AI, humanoid robots, and self-driving cars. All of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. Have a great CES, everybody. Happy New Year. Thank you.
We're speechless. Jensen's gonna take over the world, basically, with this.
gentlemen, welcome to CES 2025.
NVIDIA founder and CEO, Jensen.
Woo!